Good morning, everyone. This is the first lecture of this semester, Meteorology for 70, Climate Dynamics. I know that you choose this course because you know climate dynamics is very important in meteorology. So, can you give me some examples to show why climate dynamics is very important? Okay, I will give you three examples. First one, it can help us to understand recent climate change. Secondly, it can help us to understand Earth's history. And the last one, it can help us to predict future climate change, specifically on probability based on assignment of climate prediction. You know that climate is very important in the society. It can help a country to develop their economy, to help people to prepare their healthy life, and many things. So, how to predict climate change? It becomes the most important question need to develop in meteorology. And you know that when there is a life existed in the Earth till now, this period is only a small one compared to the entire life of Earth. And what happened before a life existed? This is a, I think it is a so interesting question, and climate dynamics can answer this question and can give you a good explanation. And climate dynamics can help you to explain all these questions. What are the records telling us? What are the proxies? What are the forcing? What components are involved? What are the time scales? What are responses? All these things can help us to make a better model to predict the future climate. And next I will give you a general picture about this course. Course description. This course covers select basic concepts of global scale climate, with emphasis on climatic and oceanic physical processes. Induction of these concepts are allowed by examples of how these processes are linked to each other to cause climate change and to bring about different climate states, which may range from a snowball Earth to equable or warm climates. Whenever possible, ideal models are used to illustrate the concepts and the physical processes. If you have questions, you can come to my office, and during this office hours, if you want to meet at other times, you can by appointment to meet me. The textbook of this course is Global Physical Climatology, and I also list three recommended textbooks: Atmosphere, Ocean, and Climate Dynamics, Principles of Atmospheric Physics and Chemistry, Physics of Climate, and other papers are listed, and you can get them through this available website. Um, Beyond this course, you can learn many useful things through these materials as a supplement. In this course, we will have two midterm exams, no final exams because there is a term project assignment. Your term project must demonstrate original through new hypotheses, interpretation, presentation, or new calculations. First, you need to maybe think about topics and then use some useful analysis to support your hypothesis. I think this project can help us to reach these three goals. First, to gain insights into the interactions among various components of the climate system. The second one, you can get insight into complexity and the working of actual phenomena that are relevant for climate. And thirdly, to improve one's ability to communicate climate science to a general audience. The term project proposal need to be submitted no later than March 14. Um, this time your proposal will not be graded. I will give you some feedback about your term project so you can get prepared for the final version. The final version it will be graded. The project graded based on the concept of the project, the written paper, and the other oral or video project presentation. This presentation will be made at the last of the last class of this semester. Collaboration are highly recommended. So you can share your ideas with other people, but you need to write your own proposal by yourself. So one person have their individual versions of proposal. At the last, I will show you two pictures to give you a general picture about the climate dynamics. This one is the recent global mean temperature. It is during the period from 1880 to 2000. You can see from the industry begin at 1880, you can see a long trend, a long warming trend till now. This is due to the greenhouse gases effect because the people emission more and more carbon dioxide, such as cars, industries, many things, and cause the Earth disshapely warming. If this warming goes on, the temperature of the entire Earth will increase about 2 degrees centigrade. It is very bad because this will cause the sea level surface rises and many cities such as islands will disappear and maybe make people need to integrate. And this period is very short in the entire life of the Earth. Now, what happened? I talked about at the beginning of the course. What happened beyond the 1880 and maybe all these 1,000 years? What the general picture of temperature is? What kind of that? I will show you next picture. This is the reconstructed temperature. Why call that reconstructed? Because the data you get is from the tree. You know that the tree can live for such long period, and such as ice sheets at the top of the mountain. This ice maybe existed 1,000 years, and also can get from oil and many materials in the soil. And we can reconstruct these figures of the temperature. You can see the first picture is just this short period compared to the entire life of the Earth. Even you can see there is a warming period during this time, but the warming rate is not as sharp as this one, and the increased temperature is not so large. So this one is more stronger compared to the period before 18,000 years, 1800 years. So during this happen, it will influence our life very much. What can we do to get this trend slowly or get the temperature return to the normally level? All these things we can use climate dynamics to explain. So during the entire semester, we will talk about this dynamics and to think about how to make a wonderful model to give a good prediction of the climate. That's all. Thank you.